Welcome, sir.
Yeah, welcome, ma'am. Oh, sorry. It is. Thank you. Shall we start?
Yes, sir, we can start.
Yeah. Yeah. Good evening, everyone. And this is one of the lectures in the areas of machine learning and data science. This is the area of deep learning and artificial neural networks. Why we want to learn deep learning and artificial neural network is what I'm going to discuss about. Particularly, I will emphasize on role of deep learning in our lives, which has been increased in last couple of years a lot. And we will see that how this particular area is going to impact our future more than we realize. So what I'll do is I will not include everything in 1 hour, but I will try to include up to artificial neural network and the activation function, and some talk about how to actually train them. So what is deep learning? So it's a sub field in the machine learning area. So we so far have talked about supervised learning and unsupervised learning. There is another part of machine learning is called reinforcement learning. So reinforcement learning is quite a bit of little different from supervised and unsupervised learning. It is a mixture of feedback and supervised learning in some sense. So reinforcement learning, you can think of a sub area of machine learning where how human beings learn. So we make some action as a being. That action can be understanding a new smell or understanding what is hot and cold. And we make an action, for example, children typically touch something new. And we are hesitant first, but we still do some exploration and take an action. And we realize that, oh, this particular kind of take an action, if it's a hot, our response will be taking our hand from that particular vessel or utensil. So that what happened is that we actually touched the utensil, and our senses say this it's hotter than we can actually tolerate. So the reward we got is that it's too hot, and the feedback we got is we should not touch something which has a lot of vapor coming out of it, because hot tea, hot coffee, we should not touch it. So reinforcement learning is that kind of concept where we reinforce learning aspect by taking some action and deciding the result of that action in terms of reward. But the deep learning is another approach which has been there in last couple of years, which is inspired from how the human brain is been evolved and the structure of human brain. And the deep learning has an impact on supervised learning, unsupervised learning, and the reinforcement learning of areas of machine learning. And it uses artificial neural networks to perform certain tasks. And what is artificial neural network is I'm going to talk about by comparing it with a biological neuron. So before we go and compare this, let me motivate you with a set of applications which we might be using or we are going to use in the near future. So deep learning has application in computer vision, natural language processing, and other data languages also. So let me start with the computer vision. So all of you have a camera, smart cameras, correct? And on that you take images, videos, everything. Also, you might have seen that sometime when you take a photo, it actually shows you or try to take a photo using your camera. Some camera shows some boxes around the faces, correct? So how did it recognize that this particular face is a human being face? So that is the recognizing the object. So in any images, recognizing the object is one of the standard task in a computer vision. This can be used for detecting the vehicles. So you have this automatic barrier opener, correct? It will look at either it will sense some code, or it using the image, it will sense that, okay, there is a car. So, and there is a number plate which has a IIT Madras logo, so it should open. Okay, so it's recognizing the object is one of the biggest challenges in computer vision, and deep learning tools have actually made it possible. Another objective is to gauge the property of the objects. What is the object's property? Whether it is an inanimate object, it's an animate object, means inanimate object is like is it a bottle or a cup or a telephone, mobile, or it is an animal or human being. So that kind of property of the object. The third aspect, particularly in video, they want to predict what the objects are doing. So many of these movies, they want to actually ensure that what is the task of the object, which is human being, or try to model the scene itself is a part of the computer vision using the deep learning. And the objective here is to deduce, plan, and reason based on this information we get from an image or video. The another one which we are widely using is the natural language processing. In the natural language processing, what is the natural languages? Tamil is a natural language, Telugu is a natural language, Hindi is a natural language, English is a natural language. The languages which we speak in terms of some sound, right? Or we write in terms of some substructure. We do not write the way we speak or way we read or way we, but sometimes we actually write in different manner, and it is provided to us in terms of data. And there's a huge amount of data available. Old records, books, publications, newspaper articles, all these are digitalized over years, and it provides huge amount of text data. Similarly, old records, old videos, all these are actually in terms of certain sounds are also actually captured, and that is become a signal in of natural language processing. So all these natural language processes is another applications where deep learning is widely used, and as a matter of fact, you are using every day. And there are other applications which are non-image and non-text database, which are being used in the industry and other part. So let me give more concrete examples of DL in the computer vision. So medical imaging. So in medical imaging, this is, you can see there are different kind of X-ray and different kind of images are there. And using this X-ray, we want to learn whether a person has a fracture or person has an abnormality or not. And for example, if I take a lung X-ray and I want to find out there is an infection or not. So machine learning and deep learning are widely using nowadays the tools to predict and say whether image belongs to disease condition or not. So basically, if I have pneumonia, I want to take a lung X-ray and find it out. Okay, there is some pleural infusion somewhere where there is some water collections happening. Medical surgery is another area where they want to actually bring a lot of deep learning. People are trying to do it at least at the lab, and maybe in the next couple of years it will come into practice. So medical imaging is one area where deep learning is making impact. For example, in our lab, we try to figure it out how to actually look at the slide of blood and find out whether you have a malaria or not. The another application is in a traffic management and control. You have seen in many places that traffic, like take a particularly in the London and some area, traffic management system try to actually ensure automatic control of the traffic by automatically switching on the green and the red light. So if there is a lot of traffic, it will actually manage between them. If there is no traffic, it will make it red and allow other people to pass. And it does as the vehicle comes. In that case, we have to actually detect there is a vehicle is waiting to cross the road. Self-driving cars is another example where we want to have autonomous vehicle which drive by itself, particularly in the car, and there the object detection is one of the most important problem. Other application is a face recognition. So I go and face recognition is one of the widely used applications. Fingerprint recognition is another widely used applications of deep learning models in many security applications as well as social media platforms. Nowadays, you will see many interesting movies throughout the entertainment, which actually use deep learning tools to create special effects and much alive picture than you can do by makeup. So, for example, here you can see that this is an artist who is playing a role of some evolved monkey, and he is actually he did not do any makeup, but he actually brings those expression on his face, and all these points are actually measured by the camera here and the other camera here to actually understand his emotion, and then there is a computer vision which actually creates this picture or video which actually capture in the character which they belong to. Remote sensing application is one of the best example of deep learning, where navigation purpose Google Maps are used. Agriculture and space research nowadays, deep learning is used particularly for the analysis of those images. The another application is natural language processing. So this is one example, Google Translator. I think all of you must have used Google Translator, correct? And here it is given in Hindi. It can be in Tamil, it can be in Malayalam, Gujarati, Telugu, anything. And we are interested in translating it in English or Spanish or Hindi to Tamil, Tamil to Hindi, correct? And Google Translator works quite well. What it does is it uses deep learning to do that. Similarly, capturing the meaning and tones of the source language is also important, and Google Translation does that. If you write what is na pair, it will, if I say na, it will actually say, most of the time, the predicted word will be pair. So, because many people use that phrase often. So, Google not only understands the translation effect, but also understand the meaning and what people want to, when they use certain tone and language, they want to actually understand what is going to be at the end of the day. Spam detection. So we might have seen there are a lot of spam mail in our Google Gmail. So spam detection also actually done using NLP techniques, which are using deep learning. Virtual agents, for example, like Siri and Alexa use deep learning. Chatbot. So if you go to some website, there is a suddenly some person is trying to talk with you. They are not the human being, but chatbots. Those actually try to respond like human level response, and try to answer some of the simple questions if you actually type certain questions. Social media sentiment analysis is another one. Text summarization is another one. So there are so many applications of deep learning in a day-to-day life, and it is going to increase then decrease. Healthcare analytics, where people are using a lot. Recommendation system. This is where you go to Amazon or Flipkart, and it will recommend you certain items based on the historical consumption and the pattern consumptions of a customers. So if I go and buy certain items, I will get a different item to recommend it. Then you and go and do it because my historical consumption pattern is different than yours. And deep learning is widely used for this one. Targeted advertisements, predictive maintenance, which is typically used in the industries, and automobile cars for how often should I maintain my vehicle. So now question is all this deep learning related questions I am talking about, but the question is what is deep learning, and what is more importantly is neural network. So biological neurons are the most important aspect in a development of artificial neuron or artificial neural network. So the artificial neuron is a small piece of a huge network. So let's look at the biological neurons. So how biological neuron works. So what is biological neuron? It is a basic working unit of the brain and nervous system. And we have a close to 100 billion interconnected neurons in a human brain. So you can now imagine how complex the brain is. That's why we have difficult time understanding the brain functions. But on the other hand, it does wonderful things, correct? Brain can give you ability to make decisions. It will give you ability to seeing well and do certain tasks, which you think it's very, very obvious as an adult, but it's very difficult for machine to do it. There is no machine which actually take set of instruction from me and do it. There is a simple machine I have seen is recently by Tesla, which actually can do certain tasks, which can actually identify the water, go identify plant, pour water, come back and put it. So that kind of complex tasks, which are for us for trivial, it's very difficult for the machines. And that's where the whole idea of deep learning and the artificial neural networks come to existence. Why human being can do such a task? Is it possible to replicate? So I'll not go to the detail of biological neuron, but we can see that there are certain component to it, which is dendrite, which takes the signals, cell body, which is soma, and the axon, which actually transmit output to the neuron or cells. So through the axon terminals. Now the question is, can we actually replicate something similar artificially in a machine? And that's where the artificial neuron comes into play. It is a mathematical model of biological neurons. So it is somehow this physical biological neurons, we want to actually write in terms of mathematics, where there are certain inputs and there are certain outputs. And we have a neuron is nothing but a function which processes the inputs to output, like we do. We, every second, every microsecond of our life, we do continuously. Whether we are sleeping, we are not sleeping, we take set of inputs and produce output. Some of the things our brain does without us realizing it. And over years, people have tried to actually mimic the biological networks through different neuron models. And the first one was Mac-Mulholland-Pitts model. It's a very simple model. What it does is it takes some binary numbers, either 0 or 1, but set of numbers. And this aggregate through something called activation function. We'll discuss about activation function sometime, to give an output y, which is either 0 or 1. So activation function, you can think simply is a logical threshold. So let's decide that this input has a certain value, then I will say that it is 0, or it is less than value, it is 1. So here 0 and 1, let me explain. how it can be. So if I think this way, that I want to find out whether some person has a normal weight or abnormal weight. So what I'll do is I'll find this x1, x2, xn, this x1, x2, xn can be a simple Boolean variable, male or female, okay, gender. They tall or short. So there is a definition for tall and short. Then I'll say what you call it, have a poor eyesight or good eyesight. Based on all of them, I want to predict that that particular person has diabetes or not. So diabetes 0, non-diabetes less. And that way I will use x1, x2, and xn as an input. So if the summation is greater than something, I will say which is the diabetic person. If it's less than that, I have said no diabetic person. Or I can just say overweight or not overweight. I will have a threshold here. So based on this input, I am going to actually construct certain output. And this function, this threshold is something which I have to learn over a time using data. So Maclaurin-Pitts models actually can explain Boolean functions very easily, and with some threshold I have given here, but they cannot do non-Boolean inputs. Okay, non-Boolean means not 1, 0, something like that. If I give heights in terms of centimeters, they cannot process it. Or if I give weight in terms of kg, they cannot process it. So because kg can be 23.5, 23.4, it can be 90.5 kg, blah, blah, blah. It can be any real number or any positive real number. Height can be any positive real number. Of course, there are biological constraints, but in general, it is possible. Okay. And deciding another problem is deciding an appropriate threshold value might be hard as number of input increases. That's very difficult. So to overcome these issues, there is a set of new models of biological neuron is provided, is called perceptron model. So the perceptron model, the inputs are real numbers. Neuron takes the weighted combination of inputs here. So we are x1, x2, xn, where they are real numbers. And we have some weights, w1, w2, wn. So the weights are basically some coefficient of x1, x2, xn, which tells what is the contribution of x1, x2, and xn to A. And there is another term called added bias, called as an extra input for sometime people add for a mathematical prediction. And then it passed through some summit and passed through some function f and produce output. This output again can be a binary like classification 0 or 1, diabetes or no diabetes, or it can be a simple number like what is the blood glucose level. So this is the model which has been proposed by proposed in subsequently. And it is called perceptron model of the system. Now you can see that for some example, I have a feature like lead actor, director, tail factor, runtime, value for movie 1 and value for movie 2. And based on that, I have decided FA is equal to 1 if A greater than 7, FA is equal to 0 otherwise. And movie 1 and movie 2 are those areas. The artificial neural network actually is nothing but the set of so many artificial neurons. And that's why it is a network. So how does it look like? Let me first, before I go behind that, this is let me start with so each of this unit you can think is a small artificial neuron. Like I told you that our brain has 100 billion biological neurons. Billion. That's not even million, it's a billion. So similarly, the artificial neuron is an entity which has several artificial neurons as its unit. And it is not as complex as the brain, but it is complex enough to actually perform certain tasks. So it takes certain inputs and it actually produces certain outputs. So this is how the artificial neuron looks like. So what is the main motivation for going for more than one perceptron model? Because often when we try to model a complex task or complex decision making, it is not sufficient to use one neuron. You cannot actually build good model. Like in a brain, where each neuron may not perform a great task, but as a collectively, they are doing wonderful job. And we all are kind of example of that our brain neural networks does so wonderful job that we can sit here, listen to it, process all kind of information. I'm sure that someone might be listening my lecture as well as watching their WhatsApp messages. That's possible. And still we, at the end of the lecture, your brain can actually come and ask a very intelligent questions. So that's very, very much ingrained in our brain over the years. Of course, it's an evolution has played a role in it. So not a single neuron make a decision, or many neurons together make a decision about going, I am thirsty or not, or I want to drink a water or not, or I want to eat, I like this food or not. That's what so many neurons make a decision. And that's why it makes sense to go for artificial neural network model than a simple perceptron or a single neuron based model. So what here we are going to do is we are going to look at the artificial neural network, which has a certain structure. So let's discuss about structure here. So it may not, because we do understand how brain works at a global level, at a macro level, or even I say nano level, we still have a difficulty understanding how different connections in a brain cells are there, and how different connections in different parts of brain actually light up together to perform very complex tasks. So artificial neural network is still a very basic unit of our biological networks. So what artificial neural network does and how it's constructed. Here we can see that it has an input. So this is the input layer, which provides different kind of input data or input features like height, weight, height, weight, BMI, etc. And the output is simple: blood glucose. You have diabetes or no diabetes. One has a diabetes. Given this data belongs to the person who has diabetes or not diabetes. So each neural network has a three kind of nodes. One is the input nodes, another is the output nodes, and in between they have a hidden nodes or layers of hidden neuron. Okay. So, and every neuron in each layer is connected to every neuron in a successive layer. So here, this one is connected, every neuron is connected to this layer. Similarly, every neuron has a connection with another neuron. Similarly, this layer, every neuron is connected to this layer. You can see, right? It's not necessary, but this is what is the first we defined it. And finally, what we have is the output of one neuron is passed as an input to another neuron. And finally, we have a final output, which takes all the last hidden layers of neurons output and construct the output of the system by processing using output layer. So with this architecture, we can look at more closely how the weights are, how they actually do it. So let's look at some simple way of solving this problem. So I have Y as my output and X1, X2, Xn as my input layer. So we have an N input. I have a L-1 hidden layers. Here I have shown 2 hidden layers. Okay, so there are 3. This is the 0th, 1, 2nd, and 3rd. So this is start with 0, then 1st, 2nd, and 3rd. The output of zeroth layer is the first layer, input of first layer. And the output of first layer is input to the second layer. And W1 and Wi and B1 and Bi are the weight matrices and bias vectors, which are basically added here. So how deep neural network or ANN in general is work is that it actually this x1 multiply with W1 plus B1, and then there is the summation of this one is done as the activation function and produces this one. So here I can see that it is called DNN feed forward calculation. So I have x1, x2, xn, and I have a multiply with W1 plus B1. So I produce this A1, which is a summation of all the inputs and the weight for each of this node. And then I will apply something called activation function on A1. So we'll discuss what kind of activation function you can do it, and the output will be H1. Now H1 here is basically now going to behave like your X, and we'll multiply H1 with W2, and it will produce A2. We'll apply function on A2 and produce H2, okay, which is the activation function. And similarly, you can do for other layers if there is a layer. If that is, it is a last layer, hidden layer, then in that case, we'll apply appropriate function here, depending on the problem. So here, if you look at it, what we are doing is we are actually having a W1 x1 plus B1 G, G's GH, and finally. So it is what this neural network is doing is approximating some function with parameter W1, W3, and B1, B2, B2, and B3. Now, what we have to understand is simple. This artificial neural network will take some data and produces the images. But to do that, we need to have all the W1, W2, W3, and B1, B2, and B3. So how to compute them from the data is the question. Before we go there, we'll discuss at least about some of the types of activation functions. So here, this G0 and GH are activation functions. So what are those functions possible? So activation functions is like a gate between input and output of a neuron. Their purpose is to introduce non-linearity into the model and enable a complex functions and models. So this thing that way that most of these the complex functions like computer vision or natural language processes, our brain has the ability to create certain patterns and certain memory and use them quickly. So our brain actually does some models which are highly non-linear in the nature. And if we want to emulate our brain, we have to actually introduce this non-linearity through certain transformation. And the activation function is those kind of transformation, which actually in a neuron takes input and produces a non-linearity. So what are the type of activation functions? There are linear activation functions, sigmoid activation functions, 10H activation function, ReLU activation function, and softmax activation function. These are different type of functions. Let me talk about first linear activation function. So linear activation function is if you take A as the input, it will provide you C into A as the output. It's a kind of line. So here you don't worry about gradient is always constant here and does not depend on the input. That's okay. That's not needed right now. Sigmoid activation is another function which actually gives a curve like this, which is between 0 and 1. And typically we use it when we want to actually predict the classes, because it is very natural activation function for classification, where we predict probability of one class versus another class. If you remember, in a classification task, we discuss about it. The only problem with this sigmoid is that it can be used for binary classification, but when we go for multi-class problem, it is not possible. So if I have two classes only, tall versus short, diabetic versus non-diabetic, yes versus no, binary class. But if I have yes, maybe, no, then three classes. Tall, medium, short, three classes. In those kind of situations, sigmoid function cannot be used. So the softmax activation functions allows us to perform tasks for a multi-class classification problem. So here the function is like this, where f of ai is equal to e raised to as divided by summation of I is equal to 1 to k e raised to ai. Okay. There is a tanh activation function. It was widely used. It brings very nice nonlinearity and extend nonlinearity from a range of function from 0 to 1 to -1 to 1. Lately, people have figured out a new class of activation function called rectified linear unit. And this linear unit provides interesting structure to the system. F of a is here, f of a is equal to max of 0 a. In other words, if the f a is negative, it will take 0 value. If a is positive, it will take value equal to the a. So it is a 0 here and equal to a in 0 greater than a greater than 0. It's one of the widely and most popular activation function, has many different variants. So there people have actually different kind of rectified linear units. Now the question is how we can take forward and do the feed forward calculation. Okay. So we'll demonstrate how people do it. If I know my weights and the biases. So simple. I have given you two features and three classes. So here the task is to classify a person as an underweight, class 1, normal weight, class 2, or overweight, class 3. And here I have given you two features about person, height and weight. So I come to the, let's say, IIT, I'll go to the class and measure height and weight of each student in a class. And my job is to use the neural network, which is trained, let's say, in your college, okay, using your student, and use that and predict whether the person in IIT is underweight, normal weight, or overweight. So here I have chosen two hidden layers and two inputs, three outputs in general. And in each of these two inputs, I have a 1, 2, and 3 neurons. So I have three neurons here, three neurons here. And for all these things, we will take a RALU activation function as for each of this one. For the last layer, we will take a softmax function. Remember, it is a multi-class problem. 3 classes, not 2. So we have to take softmax activation function. And I have given this weight W1, W2, W3, B1, B2, B3 as my example. So I'll compute A1 from the first layer here, which is W1x plus B1. So it will provide this value equal to 0.8, 3.25 minus 0.46. Now, as I told you, H1 is activation function on A1. So RALU on A1 and each element of A1. So what is RALU? RALU is basically rectified linear unit, which works like this one, f of x is equal to max of 0a. So if I look at it here, the max of 0 and 0.8 is 0.8. Max of 3.25 is 3.25. Max of 0 and minus 0.46 is 0. So here we have a 0. So this is my now H1. Now again, I'm going to put H1, use A2, apply RALU on H1, compute H2, and keep repeating till the last one. And the last one, I don't have a RALU, I have a softmax. So I have this A3, okay, which will go to the softmax. Softmax is here. If you recall, softmax here is to e raised to ai divided by summation of 1, 2, 3 e raised to ai. So if I add that, it's very obvious that these two are near to 0, while this one will be 1. So y is equal to 0, 0, 1. So what it says that for the x1 is equal to 1.5 and x2 is equal to 0.5, the person based on the weight we have is overweight. That's the class has been chosen. So this is the forward calculation. Now the question someone can ask me is following that how to choose these weights. Before we go to this, we'll discuss very briefly what is something called universal approximation theorem. So there are theory which tells you that by taking many neurons, you can actually approximate any function in the nature under the assumption that all the activation functions are non-linear. So this is one of the corner theorem that we can apply neural network to any system. Okay, so that's a theory. Let's not worry about it. Let's see how we can actually train neural network, how we can find weight matrices and bias matrices. So here for data, I have an input data and I have output data. And for regression, we have real number, and classification, we have discrete or probability of each class. And I want to find out some function f, which actually start from this data to y, which is a supervised learning. Okay. So what we have to ask, what is a suitable fx for the given data or task? Generally not known and can be complex. That's the first problem. Second one is, can we find the weights and biases which approximate desired fx using deep neural network? The answer is yes, they can be learned from the data. I have given you data, I can learn it, any complex function fx. So we have to train a DNN using this data. When I say train, what does it mean is we have to learn the weight matrices and bias vectors from the data. So how we can do it is a very interesting part. So I'll summarize this later. So I want to talk about last 10 minutes to 15 minutes about how to train DNN models. Okay, so we did all these things. Okay, so how to train a DNN model? Let's look at this slide which summarizes the DNN model. So here, if you recall, this is my neural network, which is a deep neural network model. The first task is to create a neural network, number of layers and number of neurons. So I already know I have 2 layers are fixed, input layers and output layers. When I say create a neurons, means I have to decide how many hidden layers I have to actually do, which is number of hidden layers here is R2. And in each hidden layer, how many neurons I want. 5, 20, 23, 30, 40, 100, 1000. I have to decide that. Once I do that, I will assign a random weights and biases for each of W1, W1 to W2 to W3, B1, B2, B3. Once I have this one, I have data. I am going to, for each data, I can compute Y. So pass it input X through the network and get the output. We have done that task just a couple of minutes ago. If you recall, this is the task. I have given you input data for each one. I have given you weight, and I can compute the task, the Y. Now, that's where the interesting part comes into play. When I do that, I will have the output for given X with this given weights. And what I can do is I can use these two to find out prediction error. How good my weights are, whether they are predicting well or not. If they are predicting well, I can keep those weights, but they are not predicting well. Then I have to change them, adjust them, such that it minimizes the difference between Y and Y hat. I keep repeating this one by changing weight and looking at it until for all inputs, I get overall minimum value, means Y hat is approximately Y. Until that, I keep changing my weight values and get my final neural network model. Is that clear? If I get once that, then I can go and do more work. So before I go and do the more work, I have to understand what I mean by prediction error and find out difference between actual and predicted output, prediction error. So to do that, you have to define a concept of cost function. The cost function or loss function it can be used to quantify prediction error, or sometimes you quantify it as a cross entropy loss error between two classes. So if it's regression, you use this one. It's a mean square error. If you are classes, it can be used as a cost entropy. Now, how to adjust the weights to minimize the loss function is another question. You can see this figure. You can think this as a there are set of hills here. These are hill. This is some another hill, and there are certain valleys. Correct. Now I am at this part of the hill. Now I want to go to the minimal part of the minimal of this, or I want to go to the valley of this complete landscape. This is where there is a nice restaurant where I can go and eat. So I have to go there. Now, as a human being, we try to find out the path. And that's easy because we can see. But if we cannot see this completely, what we have to do is we have to actually, if we are blind, then what we'll do is we'll try to take a step and see where I make a step, it gives me some kind of downward slope. So if you make that slope, you do that. Again, you find out all the direction in which I am actually what is slope, and you take a direction where you have a maximum reduction in the slope. You keep doing it, and finally you can reach here. Of course, if you are smart, you can directly reach here, but it sometimes creates a problem if you do not realize, because locally. So sometimes it happens that if I take a bigger jump, I might move. This is the direction in which decreasing, and rather than taking one step, I take a two step. I will reach here, and maybe end up in this valley instead of this valley, where there is nothing here. Here is a good restaurant. So I want to actually change W1 and W2 here. These are the parameters you can think of, such that I get minimum in the L. That's what I'm interested in, which is minimize the loss function. And that journey has to be done by computing a gradient at each point. So what is a gradient? Gradient is a partial derivative of L with respect to each parameters. And we'll actually we compute the gradient. The gradient can be interpreted by following: that is the value by which the loss function decreases when the parameter increases. If I increase W1, the loss function decrease is the gradient. So here the gradient of 2 with respect to W1 is says when W1 is increased by a value of 1, L is increased by value of 2. So by updating W1 as W1 plus this one and W2 as this one, we increase the loss function value. If you decrease it, then we will get a decreasing value. So that is where the whole idea of gradient descent comes into play, where gradient descent means you use gradient to descend. And here the objective here is to figure it out how I should actually update my W1 and W2 using W1 and old W1 and W2 and the gradient. So there's a whole way, this is the way you actually do it. So each time what you do is, let me summarize before we go into detail and finish the things. So what we do is following. You have a n data points, x and y, n samples. You randomly initialize these weights. And for each weights, you compute y head, which is a predicted y for each sample, and compute overall loss function L. Using this L, you calculate the gradient of loss with respect to all weights and the bias using the chain rule. The chain rule is this one. Okay, so this is a rule which is differentiation of L, which is a W1, can be decomposed into the differentiation into set of small partial differentiation, which allows you to actually each time compute each of them and compute the overall gradient. Okay. So, and the gradient calculation involves summation over all the samples. So you find for each of the sample and sum it. Once you have that, what you can do is you actually, depending on alpha is typical learning rate, and it is around 0.1, 0.2. So let's say alpha is equal to 1. Okay, don't worry about that. So with the alpha is equal to 1, what you do is you subtract this value from the old weight and biases and compute new one. With new, this is a new parameter, you compute y hat and for each sample and loss function. So you go back to A, compute all these things and repeat B, C, and D until your total loss is minimized. So every time you will see the loss is decreasing. So here you can think that if you are here, every time you follow the procedure, you slowly decrease. And finally, if you reach here, it will tell you that, okay, I cannot further minimize my loss. So this is my value. Okay. So this way you can actually train deep neural network using the data. Any questions? Because this is, I can go further, but I think this is good enough for today's class and understanding what is deep learning. But if you have more questions, you can answer. Otherwise, I'll just summarize and then maybe have a 4 or 5 minutes chat with you as a for about opportunity available in IIT Madras, some internship or something like that. Okay, if you don't have a question, so let me summarize what is a deep neural network. So deep neural network is an artificial neural network which can perform many complex tasks and will perform in coming days more and more complex tasks. And hopefully one day we'll have autonomous systems which will perform tasks as complex as human being or even more complex than human being can do. What we need for deep learning model training, we need a data and the choice of the model, which is basically neural network. How many nodes, how many neurons in each hidden layers, and how many layers. We have to learn parameters from the data, which is W1 to WL from this data. To do that, we need to define a loss function, which is typically mean square error for the regression and cost entropy for the classification. And then we need a training algorithms like gradient descent with the back propagation, which allow us to use this data, update the parameters such that after some iteration, we minimize the loss function. Okay, that is what is a neural network is all about. There are a lot of details are there. I'm not going to talk about this detail. So, do you have any questions regarding the opportunity at IIT Madras? So let me do one thing. I'll share with you something which I'm sharing. Which in meanwhile, if you have a question, you please let me know. No problem. Okay. Okay. Let me list.
Excuse me, sir, the section is over.
Yeah, lecture is more or less over. Maybe I can present some opportunity available for female students at IIT Madras. at IIT Madras. So just 1 or 2 minutes more. So we have a center at IIT Madras called Robert Bosch Center for Data Science and AI, who provides different opportunities to work with us and with a good stipend for 1 year, 2 years. It is called postbaccalaureate program, which is specially designed for students who have passed out or graduated recently, a master as well as undergrad, MSc, mathematics, statistician, MCA, computer science. And this program, we have special program for the women. So since I'm talking in a women's college, I thought I should at least tell that this is the program you can always apply. It is exclusively for women, and
Thus, if any doubt, please clarify.
yeah. If you have any doubt, you let us know, or you can send an email to me, or talk with Indumati. She's going to teach. Indumati and Pranay we're going to teach sometime in November on the practical classes. So this is a round year email. Please send an email if you are interested working with us. We have very great faculty as well as students who are working in the area of data science. Okay, thank you.
Thank you so much, sir,
Yeah, thank
for the wonderful sessions. Rameshri, can you please proceed, ma'am?
Yes, ma'am.
Okay, can you proceed with the vote of thanks?
Okay.
Speak only.
I extend a really hearty word of thanks to our chief guest, Dr. Nirav Bhatt from IIT Madras, who spared time for his busy schedule to grace the occasion. Today, we have an opportunity to hear your thoughts, and this will surely be going to encourage us in our future events. I am immensely thankful to Mrs. Rajarajeshwari ma'am for arranging this wonderful session. And also, I would like to thank Dr. Kanakadurga ma'am for her efforts towards anchoring of today. His own ideas and elegance of explanations of everything, I need to mention my deepest sense of appreciation. I also extend thanks to all the staff members for their enormous cooperation. A special thanks to our respected principal, Dr. Vanati ma'am, for being the catalyst that stimulated us to do our best and standing as pillars of strength. With a deep sense of appreciation, we thank our loving teachers for their untiring efforts. I would also like to thank the people who worked behind the scene to make this event happen. Once again, thank you very much to all. Thank you, sir.
Yeah, thank you everyone. Yeah. Please write an email or talk with Indumati if you have any problem. Yeah, thanks. Yeah. Have a nice evening.